Welcome to GDP's Graphics 1 2019. My name is Felipe Bellini and this is a video demonstration for Project 1 addressing the classes lecture by Michael Finney. All the information and source regarding this project can be found both at GitHub and Fanshawe Online. Project 1 features creating and loading a 3D scene using OpenGL. A scene may be composed by models, lights, sounds, or any other assets that are crucial to a game design. Now, let's take a look at the code. Open Project 1's solution in Visual Studio 2019. This solution features two main projects, Bell Engine and OpenGL Proj. Bell Engine is the core component of this project. It contains all the code that can be reused across multiple game projects. It has objects such as game object, rigid body, managers for sound, GPU, and physics. Bell Engine summarizes the content that was studied during class. OpenGL Proj can be thought as the game itself. It is built upon Bell Engine, featuring custom tailored content as opposed to the engine. Here, we will find the actual game loop in OpenGL-project.cpp, the level loader, which builds our level design, loads game objects and meshes, and the user control, which will handle user interaction with the game. It is important to mention that the content displayed by the game, also known as the level, is dynamically loaded from a file. The current state of our level can also be exported to a file of the same format. This is a reference to level loader and state saver. This is also true for the game configuration, such as screen proportions and the keyboard controls for user interaction. This is a reference to game config and key bindings. Now let's take a look at our descriptor files. These can be found at OpenGL project folder, assets, then config. If you're using the binaries, it should be at the root folder. Let's take a look at our descriptor files. These can be found at OpenGL project folder, assets, then config. If you're using the binaries, the assets folder should be located at the root of opengl.exe. First, the game CFG file. This contains general properties of the game. As we can see here, we have window properties and the control bindings. These values on our right are as according to the GLFW3 header. Users can change these to have other combination of controls. Now let's rebuild the solution and run from the bin folder. During compile time, Bell Engine and the Assets folder are automatically copied to the binaries directory. I'm choosing to run the project from the bin directory for performance reasons. As we can see, the OpenGL project has loaded our level. This is exactly as described as the level.xml file. For this project, many controls were implemented for user interaction. These controls are all mapped out on the controls.docx. This file can be found at the same folder as the solution. Some of the control availables are the camera. We can zoom in and zoom out using the mouse wheel. And there's also controls for the game objects and the lights. There are three modifiers that are being used in this project: Ctrl, Alt, and Shift. Ctrl will be used for the game objects. Shift will be used for the lights, and Alt for generic commands, such as selecting axis or the RGB bits. Let's select a game object and see what we can do with it. I'm going to select one of the trees. Notice there is a cone on top of the tree. This is our selector object. With the tree selected, we can move it, we can scale it up or down. We can change its color by pressing Ctrl and moving up or down the mouse wheel. We can rotate it in any axis needed. Remember to press Alt to select an axis. This is also valid for changing colors. Notice that on our console window, it's showing up every time I select something. Game objects can also be changed between wireframe and GL fill views. Press Ctrl and F2 for that. There's also the possibility of applying forces to an object. Press Ctrl and the arrow keys for that. Notice that this is different than simply changing the position of the object. Let's move on to the lights. The Shift keys will help us select the lights. By pressing Shift, dot, and comma, we can select between the lights. The green selector means that we have selected a light. Let's see what we can do with it. Lights can be turned on and off using Shift F2. Their attenuations can be changed, increased or decreased. There's also possible to change quadratic attenuation and the rotation of lights depending on the light type. For this project, we're using spotlights and point lights. As an example, let's try to increase the linear attenuation of the moonlight. We can see a big difference in the environment. Let's select the light of the water tower and try to change its angle. Use Shift and Z or X to change the angle along any axis you'd like to. There are 10 total lights in this project. 2 for the tractor headlights, 1 for the fire, 4 for the UFO. There's a light in the water tower, and there's also a light in the barn. Not to mention the moonlight. This concludes our presentation. For more information, reach out to Felipe Bellini or Professor Michael Feeney at Fanshawe College. Thank you.